So in this video, you're going to have to discuss about the equation of a sphere. So what is a sphere? Now this is a circle on the three-dimensional coordinate system. That is a sphere. Let's say we have a sphere. Should be on a three-dimensional coordinate system. Let's say that's the case. And assuming that it is having a center given as x naught, y naught, as well as this naught. Mind you, this is three-dimensional coordinate system. In the analysis, want to be different with that of a circle, equation of a circle, but only different is that we'll be having a three-dimensional coordinate system. That is for a sphere. And let's say we have a point along the sphere. And let's say the point consists with the coordinates given as x, y, as well as the z. Let's say that's the case. So now let's think of connecting the line from the center to the point on the circumference of the sphere, given us that. So now the distance from the center to the circumference of the sphere is said to be the radius. So that is the radius. So now using the distance formula, what is the length of that radius? So which means we'll have a radius is equal to, of course we can have it as a radius square. So should be r square is equal to, now we'll have it as x minus x naught square. Now should be that. And plus y minus y naught a square plus, now should be z minus z naught in the square. So in that case, now where x naught, y naught, as well as the z naught, those are the coordinates at the center. And in this case, this is the radius of a sphere. So in this case, this is what we call the equation of a sphere. That is the standard form of the equation of a sphere. It also can be given as radius is equal, that should be the square of x, should be x, can be this. Let me just have to present it this way. So we can also have it in this way. That is the same as well. We can have it as the radius is equal to the square of whatever I have it here. So which means if we have the radius in the center, we can be able to have the equation of a sphere in this niche, where x, y, as well as z, these are the variables. And let's try to go through the following problems that you have the standard equation of a sphere. Let's say we have a sphere with the center coordinates given us, let's say 0, 2, 5. Let's say that's the case, and the radius is given as 2. So what is the equation of a sphere if this is the case? So principle remains the same. The equation of a sphere says that r square is equal to x minus x naught to the power 2 plus y minus y naught to the power 2 and plus z minus z naught, that is to the power 2. So take note of that. And what is the radius? So have it as a 4 in this case, because 2 to the power 2 is given as 4. To have x minus, and this is x naught, y naught, and this is the z naught. Now, which means we can have it as up to the x minus l to the power 2 plus y minus 2 to the power 2 plus, and that of z minus 5 to the power 2. Now we should have it as 4 is equal to x squared plus y minus 2 to the power 2 plus z minus 5 to the power 2. So this is the equation of a sphere. And what if we have, let's say this case, let's say we have a center coordinates given as 4, negative 1, let's say, 1. And the radius is given as the square of 5. So what is the equation of this particular sphere? So principle remains the same, of which this is x naught, y naught, and this is z naught. So take note of that. So now the equation given as r square is equal to x minus x naught to the power 2 plus y minus y naught to the power 2 and the plus c minus c naught to the power 2. So which means we'll have the square root of 5 and that to the power 2, which is equal to x minus 4 to the power 2 and plus y plus 1 to the power 2 plus, or should be c minus 1 to the power 2, which is the same as 5 is equal to x minus 4 to the power 2 and plus y plus 1 power 2 plus now z minus 1 to the power 2. So now this is the equation of SFE in that case. So take note of that. So what if we are given the endpoints of the diameter of a sphere? Let's say this is the case, and assuming that we have been given the endpoints of the diameter of a sphere. So diameter is the line drawn from one side of the sphere to the other side and passes through this. Let's say this is the center, and I say we have 2, 1, 2. Let's say this is the case, and also here we have, let's say, -5, 4, let's say 6. So what is the equation of actually this sphere? So now first thing, we should have to calculate the center coordinates by having the midpoint of the diameter. Then from there we'll be able to have the radius of a circle, either from the center to this point or to this point. Now have the radius as well as the center, will be able to have the equation of a sphere. So in that case, try to have that one at your own time. So you should just have to try that one. And also, what if we have the endpoints of the diameter given us? Let's say 4, 5, 10, and let's say we have -1, -1, -1. Find the equation of a sphere if these are the endpoints of the diameter using the same principle. And also, you have to try to go through this one. Let's say we have 2, -1, let's say square root of 2. Now we have 0, 0, let's say 2. You should also just have to try to have the equation of that actually sphere with those endpoints of the diameter. So take note of that. So now let's consider this case as well. Let's say we have actually the sphere with a center coordinates given as, let's say, 2, 2, 2. Let's say that's the case, and the radius is given us, let's say, 2 as well. So what is the equation of actually this sphere? So have it as 4 is equal to now x minus 2 to the power 2 and plus y minus 2 to the power 2 and plus c minus 2 should be to the power 2. So now let's further let's further simplify these actual expressions as far as the algebra is concerned. So it is the same way we did with the actual equation of a actual circle. So which means we'll have to expand this one as well. So let's have them. So x minus 2 times x minus 2. That will be the same as, so which means we'll have it as x squared and minus 4x and plus 4. And how about x minus, so actually should be y minus 2. So it should be y minus 2 times y minus 2. That will be given us y squared and minus 4y plus 4. And how about the z square? So z minus 2 and the times z minus 2, of which we have it as z square minus 4z plus 4. That is the essence behind. So which means we can do this. So in this case we'll have it as f4 is equal to x squared minus 4x plus 4, and that plus y squared plus, so should be minus 4y and the plus 4, and the plus z squared minus 4z, and that should be a plus, plus 4. So now let's think of having the right terms together. I'll have it as 4 is equal to, so this 4, this 4, and this 4, we'll have it as 12. So have x squared, so have x squared minus 4x plus y squared minus 4y plus z squared minus 4z, and that should be plus 12. And of which this is the same as having it as x squared and plus 4x can be this, of course, x squared plus, so plus can be y squared plus z squared, and that should be minus 4x minus 4y minus, let's say, 4z, and plus 12 minus 4 is equal to 0. So that can be the way out as well. So keep that in mind. And let me have it proper here. We'll have it as x squared plus y squared plus z squared minus 4x minus 4y minus 4z, and plus 8 is equal to 0. Now this is also another, actually, a way in which the equation of SFA can be presented. So take note of that. So now, given that form of the equation of SFA, how can we be able to have the center as well as the radius of that particular SFA if this is the case? So now, the same way we did with actually SA equations, the same way we can have to express it here. So we use what you call a completing square, a process to have this expression, actually this equation of SA, actually of a sphere, to be in a standard form. So that we can be able to have the center as well as the radius of this particular actually sphere. So how do you go about that? So now, first thing, we ensure that if we have any constant number actually to the right hand side of equal sign, it has to be brought to the other side. So that's the first thing to ensure about. So in this case, 8 will be transferred to this side. At the same time, bring actually x family, y family, as well as the z families together. So which means we'll have x squared and then minus 4x. This is the one family. And I'll have y squared minus 4y, and also this is the one family. And I'll have z squared minus 4z. This is also the one family, and which is equal to negative 8. So now, in these three families, if we tend to compare with a quadratic actually expression, what is lacking is the value of the constant, which is c. So have to indicate that the c's are missing in these actual families. So in that case, we'll have, in this case, so have it as x squared minus 4x plus c1, that is the c for x family. And we'll have that, and the plus y squared minus 4y, and the plus c2, that is the c for actually y family. We'll have it as plus z squared minus, should be minus 4z plus c3, that is the c for z family. Now which is that? Now which is equal to negative 8. So now these value of c should also be introduced to the other side, so which means we'll have it as negative 8 plus c1 plus c2 plus c3. So it is the same way we discussed about this when we were discussing about the equation of a set. So how should we be able to have the value of the c's? So we use the formula which says that a constant c is given as the b over 2 over the power 2. That is the formula that we use. That is if we compare with a quadratic actually expression. So let's start with this one. What is the value of b? We have it as negative 4. So which means the c1 will be given as negative 4 over 2 and over the power 2. That will be given as the 4. So which means the c1 is given as actually a positive 4, of which even the c2 also have it the same, even the c3 also have it the positive 4. So in this case we'll have it as x squared minus 4x plus 4, that is in the plus y squared minus 4y. We also have it as plus 4, and I'll have z squared minus 4z, and plus 4 should be that, and which is equal to negative 8 plus 4 plus 4 and plus 4, since the value the value of c's are the same. So bear that in mind. So now from there we should have to simplify where it is necessary. Just have to have the like terms and some stuff. So in this case we'll have it as, now we'll have to eliminate the middle terms in the for each family, but their signs has to be given to the calculated value of c's. So which means we'll have x squared and the minus 4, as we are to omit the middle term, but each sign has to be given to this actually c. So have it as that one. So should be that, and plus y squared minus 4 should be that, and plus z squared minus 4 should be that, and which is equal to, so in this case we'll have it as should be a positive 4. So take note of that. So that one. So you should have to express the negative 4, negative 4, and negative 4 to have a power of 2. So which means we'll have x squared minus 2 to the power 2, and should be that, and plus y squared minus 2 to the power 2 should be that, plus z squared minus 2 to the power 2, which is that which is equal to 4. Now for this case we'll have it as x minus 2 to the power 2 plus y minus 2 to the power 2 plus should be now a z minus 2 to the power 2, which is equal to 4. Now that is, you should have to understand. Now this is the standard form of the equation of a sphere. So now as you can see, the radius will be given as the square root of 4, that which is equal to 2. And what is the center? I'll have it as should be 2, 2 as well as the 2. So you can see that what we have at the radius and the center, it is the same as what we had before. So that is pretty fine and true. So how about if we have this case? Let's say you have the equation of a sphere given as, let's say x squared plus y squared plus z squared, let's say minus 2x, and plus 6y, and let's say plus 8z, and plus 1 is equal to 0. So what is the center as well as the radius of this particular actual sphere? So principle remains the same. If we have any sort of a constant, it should be transferred to the other side, and I should have to bring the families together. I'll have x family, that is x minus 2x, that is that. Let me just have to include what are the, should be that, but so that is in the plus y family, that is y square plus 6y like that, and z square plus 8z, which is equal to -1. That is the principle behind. So now, as you can see, we'll have to include the missing parameters as we compare with respect to the quadratic expression in these families. So we'll have it as now x squared minus 2x plus c1, and that one plus y squared plus 6y plus c2, and the third one in the plus now should be z squared plus 8z plus c3, and that should be that, and which is equal to -1 plus c1 plus c2 and then plus c3. We can have something in that. So let's start with this one. C1 will be given as, now we have the b which is given as the -2. So now which means we'll have -2 over 2 and over the part 2. That will be given as 1. And how about the c2? We'll have it as, now we have b as being given as 6. So which means we'll have 6 over 2, the part 2, that will be given as the 9. And how about the c3? Now in this case, the b is given as should be 8. Now in this case, that we'll have it as 8 over 2, the part 2, that will be given the 16. So take note of that. So now which means we can have it in this case now. Now we'll have it as should be now x squared and minus x squared minus 2x and plus 1, that is in the plus y squared plus 6y and plus 9, and which is plus should be z squared plus 8z plus 16, should be that, and which is equal to -1 plus 1 plus 9 plus 16. So take note of that. And how should we be able to go over that? Now you should have to eliminate the middle terms in each family, and their respective signs has to be given to the actual c's. So in this case, we'll have x squared minus 1 like that, and y squared plus 9, and that plus z squared plus should be 16, and which is equal to, we have here 0, and what is that one? So we'll have it as 25. So that is given as 25. So in this case, we'll have to express this actually a value of c's to have the power of 2, since they are always said to be the perfect squares. Always it has to be a perfect square. So I have x squared minus 1 to the power 2. That one should be now plus. Here we should have it as plus. Here should be plus there. So plus y squared plus 3 to the power 2, and that one plus z squared plus 4 to the power 2, that one, which is equal to 25. So in this case, we'll have it as x minus 1 over the power 2 plus y plus 3 and the power 2 and plus z plus 4 and over the power 2, now which is equal to 5. Now as you can see, this is the standard form of the equation of SFE, in the sense that we have the radius given as the square root 5, which is given as 5. And what is the center? The center will have it as a positive 1, negative should be 3, and -4. So that is the center of the actual circle. So take note of that. And how about if we have this case? Let's say we have a case that is given as, let's say, 4x squared and plus 4y squared, and let's say plus 4z squared, and minus 24x. That can be that minus 4y and plus 80z and minus 23, which is equal to 0. So now there's something different because x square, y square, as well as the z square are having the coefficients other than 1, of which always the coefficients has to be 1, has to be the positive one. So in this case, we'll have to divide everything by a 4 to make sure that the coefficients are positive 1. And it is impossible that we can have them in different coefficients. No. If they are to have the coefficients other than 1, then the coefficients has to be the same. So in this case, we'll have it as x squared plus y squared plus z squared minus 24x over 4. We should have to divide everything by 4. And I know what will happen there. From there, you'll be able to have the equation. Actually, it should be a center as well as the radius of the polygram, actually a sphere. So now you get it. Now what if we have this case? You also try this one as well. Let's say we have 9x squared, let's say plus 9y squared and plus 9z squared. As I've already said that it is very impossible that we can have different a coefficient there. The coefficient has to be the same. And let's say we have minus 6x and plus 18y, let's say plus 1, and which is equal to 0. So what is the center as well as the radius of this particular sphere? So now let's have to bring these formulas together. Now first thing, we should have to remove the coefficients by dividing everything by 9, in the sense that we have x squared plus y squared plus z squared minus 6x over 9 and plus 2y and plus 1 over 9, which is equal to 0. That's what will happen. Everything has to be divided by 9, of which 0 over 9 is the same as 0. Now have it as x squared minus should be 6x over 9. Of course, that is the family. And I'll have plus y squared. The minus actually should be plus 2y. That is the family. But for z square, we do not have its choric. So we indicate it. We'll have to indicate it as we'll have it as plus 0z. So we'll have to regard b as a cell. The things work properly. So have that which is equal to negative 1 over 9. That's how it works. So in this case, we have the b being given as negative 6 over 9, and here we have a positive 2, and here we have b we have b being given as a cell. So everything will actually perfectly try to have the center as well as the radius of the particular sphere in that way. So at the end time, also try to have to go. You should have to try to go through this one as well. Let's say we have 9 over 7 x squared plus 9 over 7 y squared plus z should be 9 over 7 should be z squared, the minus 6x, which is equal to 4. What is the center as well as the radius of the sphere? So thank you.